Hello students, in this video we're going to continue our investigation of factors of numbers. This time we're going to be looking at how we can find the prime factors of a number. Now a prime number, if we quickly remember, and we can look down here at these descriptions, a prime number is any number that only has its own factors of 1 and itself. So 1 and itself. So for example, the number 2 is a prime factor, so it only has 1 multiplied by 2 to get the number 2. Same with 3, same with 5, same with 7, but don't get tricked into thinking it's mostly odd numbers, because for example 15 has not just 1 and 15, also has 3 and 5 as factors, so it would not be a prime number. The other term we want to know here is composite, and basically composite is any number that has more than 2 sets of factors. So they're always going to have, remember, 1 and themselves, so we're looking at something else. So again, 15 would be a composite number because it not only has 1 and itself, so that's one set of factors, it also has 3 and 5 as a set of factors, so it would be considered a composite number. Now we're going to look at a method called factor trees, or some might call them as prime factor trees, to help us find what those prime factors are. And it's very, very straightforward, and you can read through the steps here. But what I'm going to do is I'm going to do this one first and show you how it works, and then you can come back and read. Actually, no, I'll go through it here actually. So what we do, and mainly because I can't draw on the screen, I just remembered. So what we have is our number that we're starting with, the number 12. So what we do is we pick any 2 factors, so any 2 numbers that can multiply together to give us the number 12. So in this case, in the example, they chose 4 and 3. So of course 4 times 3 would give us the number above, being 12. We now look at those numbers that we just chose, 4 and 3, and we decide if any of them are prime. So first of all, is the number 4 prime? Well, no, it's not, because you not only have 1 times 4, you also have 2 times 2. So it's a composite number. So we don't consider that one to be prime, but 3 is, because it only has 1 times 3 to give us 3. So what we do is we circle that. In this case, they put an orange circle around it and they put green squares around. That's not really important, but we basically indicate, and I usually just circle that prime number, and that branch does not continue any further. We then look at what branches we have left. So we have this 4 branch left. So we again find any 2 factors, or sorry, any factor pair or any 2 numbers basically that multiply together to give 4. So in this case, 2 times 2 will give 4. We look at those numbers that we've just chosen and we decide again if they are prime numbers. So in this case, again, 2 is a prime number in both cases. So now they get circled to indicate they're prime. And as soon as all the branches we have made have got a prime number finishing them off, we now have all the prime factors. And we write that out into what we call the expanded notation by simply writing each of the prime numbers out, preferably in ascending order, so from smallest to largest with a comma between them. So the prime factors of 12 are 2, 2 and 3. Sorry, not with a comma, my apologies, with a multiplication symbol between them, I should say. So 2 times 2 times 3 will give you the number 12. Okay, so that's what we can see here. 12 as prime factors is 2 times 2 times 3. So we have a look at a slightly bigger example down here. We started with the number 360, and they chose to start with 30 times 12. And you could technically start with anything. You could do 36 times 10, any set of numbers. You do 15 times 24. It does not matter what pair you start with. You'll always end up in the same place. But they chose 30 times 12, which is perfectly fine. And then if we start over here with this branch, what numbers, are 30 and 12 prime? No, they're not. So now we start over here. What 2 numbers multiply to give you 30? Well, I chose 15 and 2. And again, you could choose any set of numbers. It might change the number of branches you do, but you'll still end up in the same place. So 15 and 2, well, 15 is not prime, so we keep going. So 2 numbers that give you 15 are 3 and 5. And we, of course, know that 3 and 5 are prime, so they get circled. We go back to this line here that we haven't finished. So we look at that. Well, it's 2 prime. Yes, it is. So that branch has finished. So coming back through, we now go through the 12 branch. 2 numbers that give you 12 are 4 and 3. Is 4 a prime number? No. Is 3 a prime number? Yes, so that one got circled. So now we finish off the 4 branch, and as we know before, 2 times 2 will give you 4, and they are prime numbers. So all our prime numbers are 3, 5, 2, 2, 2, and 3. So we can see down the bottom here, 360 equals 3 times 5 times 2 times 2 times 2 times 3. Preferably we rewrite that into ascending order, and again, because they're all multiplication, we know we can move them around, we can reorder. So this is a preferred example here, where we go from the smallest numbers, so 2 times 2 times 2 times 3 times 3 times 5. So we get that down here. But then we can also go one step further, as we've been learning about index form or index notation. We have 2 times 2 times 2 here. So we know that we can show that's 2 to the power of 3, just like it is down the bottom here, multiplied by 3 times 3. Well, that is the same as saying 3 squared. And we have 1 times 5 on the end, so that just gets added on. Okay, so we could write in the simplest form, if you like, is the index form here, where we have 2 to the power of 3, or 2 cubed, times 3 squared times 5. And of course, if we need to work that out later, we could either expand it back out to look like this, or we'd be able to put that directly into our calculator if we needed to. So underneath here, they have a little applet / video you can use to do some practice of those if you'd like to, so you're welcome to have a play with that. And then the last section here is about finding all the factors of a number. Now, we did that previously by using our t-charts, where we had our t and found all the numbers down one side and the other side. And I'm going to suggest that you maybe continue to use that method. You can certainly use this method here, but I think it could be a little bit more confusing for you, because it requires you to find every combination of these numbers, these prime factors that we've found. If you're okay doing that, that's fine, but it could be a little bit confusing, especially as the amount of prime numbers increases. So we can see here, it can get a little bit messy. So I think for these questions anyway, it's still easier to use your t-chart that we've been doing. Okay, let's now have a look at the sample questions. So the first sample question actually says a number has the following tree. There it is, a prime factor tree. It wants us to work out what the number originally was, the number at the top. Now, that's quite easy because we're just backtracking here. So we're just basically looking at what do we do with these prime numbers to get back to where it was. Well, we've got these prime numbers because they are factors of the number above, which means if we multiply these two together, we will get the original number from the green box. So let me get my little writing thing here. Now, I'm sorry it gets a little bit grayed out, but we're simply going to do 5 times 3, which of course is 15, which is going to be the answer there. And let's do this side here. 11 times 2 is going to be 22. So you can see I'm just working back up my tree. Now 15 times 3 is going to be 45. I can't quite make that fit in the box. And 22 times 2 is going to be 44. Okay, and now I have to do 45 times 44. Of course, I can do that 45 times 44 in my book, and that's really what I should be doing. So let's do that now. So 4 times 5 is 20. 4 times 4 is 16, plus the 2 is 18. Start the next row with a 0. 4 times 5 again is 20. And 4 times 4 again is 16, plus a 2 is 18. So this, of course, becomes an addition. And we've got 0 and 0 being 0, 0 and 8 being 8, 8 and 1 being 9, and of course the 1 and nothing being a 1. So our final answer is 1,980. Of course, I'm not going to be able to write that in the square, but I'll write it next to it. So we will literally just backtracking up through our prime factors, through the group of factors until we got to the original number. So if we've done our maths correctly, our number 1980 should be correct. And there we go, we are correct. For this second question, we're going to be finding the prime factors of 148, and we're going to leave them in expanded form. So we're not going to shrink them down potentially into index notation. We're just going to keep them as a set of numbers multiplied together. So we're going to use that tree for factoring that we just saw before. So we're going to do that here. So let me get my sketching. So we've got 148 as our top number, and we're looking for two numbers that can multiply together to get 148. Now, because this 148 is an even number, ending with an even number here, we can easily go with just 2 and obviously whatever half of 148 is. And that's perfectly fine. So it's a quick and easy way to get started. So 148 divided by 2 is going to be 74. Now, 2 we know straight away is a prime number, so we can circle that, and that branch has actually finished. Now the question is, what are two numbers that multiply together to give 74? So again, it happens to be an even number with a 4 on the end, so we can again go with 2 and half of 74, which is going to be 35, 37, like that. And again, we know that 2 is a prime number. Now the question is, what are two numbers that go together or multiply together to give 37? So 37 is also a prime number, so I'm going to circle that one. Now you might have to do some checking of that to see which numbers actually were factors, but it turns out 37 is a prime number. So what we then have is our prime numbers are, prime factors of 148, 2, 2, and 37. So to write that in expanded form, we simply write 2 times 2 times 37. Okay, and again, we prefer these to be in this order, in increasing order. So the 2's first and then the 37. So I come back here to enter it in. I have 2. Remember to make sure you do the multiply symbol and not the letter X. So 2 times 2 times 37. And we'll submit that to see if we're correct. Yes, we are. The last example they have is, in this question, we'll be finding the factors of 18. Now, first it wants us to write 18 as a product of prime factors in expanded form. So again, just like we did before. So let's start with 18 at the top. And we want two numbers that give us 18. So let's just go simply with 2 and 9. 2, of course, is a prime number, so we can circle that. And we need to look at what numbers give us 9. Well, 3 times 3 gives us 9. And of course 3 and 3 are both prime numbers, so they get circled, and that means we've got all our prime numbers now because all the branches have been finished. So our prime factors are 2 times 3 times 3. So to answer this first part of the question, we're going to again write 2 multiplied by 3 multiplied by 3, and that's the preferred order again because we want to go ascending order, so smallest to biggest numbers. So let's see if we're correct so far. Yes, we are. Now it says using your answers from part A, so using these prime factors, it wants us to list all the factors of 18 as separated, and separate them by commas. So this is that one that in the work lesson it was doing these tables. Now again, if you would like to do a table like this, you are perfectly welcome to. The idea is that you need to find every combination of 2, 3, and 3, and that will give you all of the factors of 18. But instead, I'm going to stick with the T chart that we were doing previously. So we've got 18 up the top. So 1 and 18, of course, are the first factors because you always have 1 and the number. 2 and 9 will be factors. Now is 3. So the question is, can we divide 18 divided by 3? Does that work? And of course it does. That is 6. So 3 and 6. Does 18 divide by 4? Well, we can do that on our calculator. 18 divided by 4, and it doesn't because that's 4.5. 5, well, we know 5 doesn't because 5 would be 15. And then we're back to 6. Okay, so we do that arrow around so we've seen them all. And so what we have now is all the factors are 1, 2, 3. So again, we're going down this line, go back up the other side, 6, 9, 18. That's what it wants us to end up with. So while we didn't do it using the table that they've asked for, we certainly have found all the factors. So if we come back over here and put them in, remembering separating by commas, so 1, 2, 3, 6, 9, 18, that will be the correct answer. Okay, so again, if you want to try and do the table, that will work, but I personally find this method to be a lot easier and less confusing, unless you're really good at finding all the combinations. So that is basically today's lesson. That is what we're looking at from the lesson itself and also the sample questions. So as always, have a read through this for yourself if you need to. Watch back over those examples and have a go at them yourself, and then head off and have a go at the questions assigned to you for today.